In this video here, we're going to take a look at the center of mass of a set of particles on a straight line. Now, to begin with here, let's just quickly recap then what we mean here by the center of mass. So the center of mass is the point at which the entire mass of a body can be said to be concentrated. What we can do here then is find the center of mass of a set of particles arranged along a straight line by considering moments. And we're going to use the fact then that the sum here of mi times xi is equal to x bar times the sum here of mi. So what does all of this mean here? So mi is the mass of a given particle, right? So that's the mass of the ith particle times by xi here. So xi then is your perpendicular distance from the origin, okay, for the ith particle. Now, in this case here, we can simplify this result, right? So this is just the same then as x bar times the sum here of mi. So this is the sum then of the masses here for all of our particles, right? There should be a subscript here for our summation, right? So this would be from I equals 1 to n. You'll see that a little bit later on when I give this more formally. So we're going to sum all the masses here for the particles. And then x bar here, essentially, is the center of mass, right? So to formalize this here then, if we have a system of n particles with masses m1, m2, so on and so on, up to mn, and they're placed along the x-axis at the points x10, x20, so on and so on, up to xn0, respectively, then in that case here, we obtain this result here. So as I said then, the limits here of our summation are given appropriately. So from I equals 1 to n here, as you can see, the actual result is pretty much identical with the exception here of the limits. And x bar 0 here is the position of the center of mass of the system. Now, what we can do here is take this result and rearrange this, okay? Now, what we want to find here is x bar. X bar is the position of the center of mass of the system. Clearly, that's the whole point of this video, right? We're looking for the center of mass of a set of particles on a straight line. So if we're going to rearrange this here, clearly we're going to make x bar the subject of this relationship here, or this result here. So in that case, then what do we actually get here? So we get x bar is equal to, so essentially all I do here is just divide both sides then by this summation here, right? So what we get here is the summation, so the summation here of mi xi from I equals 1 to n. And that's all over then the summation here of mi from I equals 1 to n, right? So the summation here of mi from I equals 1 to n, okay? Using this result here then, as you can see, it's really quite easy to actually find the center of mass of a given system, right? Where all the particles just lie on a straight line. And just know here as well then that you can also adapt this result for a system of particles that are placed along the y-axis, right? So just in case you was curious as well, then clearly we can also adapt this here when the particles just lie along the y-axis. And as you can see, the only difference here is rather than it being xi and x bar, we replace that with yr and y bar, okay? So in terms of an introduction here, this is all very straightforward, and you're not really going to get an exam question that is just primarily on the center of mass of a set of particles that lie on a straight line. It's very, very basic. However, this does serve as essentially the fundamentals to the whole of this chapter, right, on centers of mass. So it is important that you do understand these concepts and you are familiar with these results here and these relationships. So please do make a note here. And then to finish with, right, so that concludes this introduction. All we're going to do here is just work through one practice question together. So let's just get started then with question 1, or this practice question, I should say. So let's just get started then with this practice question here. Now for this question, then what we've got here is a system of 3 particles with these masses here. So 2 kg, 4 kg, and 6 kg. And they're placed on the x-axis at these points here. So 2, 0, 5, 0, and 3, 0 respectively. Now for this question then, all we want to do here is to find the center of mass of the system. And as you would imagine here, this is a pretty straightforward question, right? But let's just work through it anyway. Now clearly what we're looking for here is just the center of mass of the system. But the result that we use will change depending on whether we're looking along the x-axis here, so whether my points or my particles here lie on the x-axis or whether they lie on the y-axis. Now clearly, just by reading the question here, and as we can deduce from the given coordinates here, clearly these particles here lie along the x-axis, but if they did lie along the y-axis, it doesn't change things too much, but you do need to just be slightly careful, okay? Now, given that they lie along the x-axis here, clearly what we're looking for here then is x bar. So we want x bar here. And just as a quick point then, if these did lie along the y-axis, then clearly we'd want y bar, but they lie along the x-axis, right? So we want x bar here. And as we demonstrated then within the introduction here, we do have a rearrange form then that will allow us to easily calculate x bar, okay? So what is that result then? So this here is the summation from I equals 1 to n of mi times xi, all over then the summation here, again from I equals 1 to n of mi, okay? So for the numerator here then, nice and straightforward. All we do here is we take the respective masses, I should say take the masses and multiply that by the respective perpendicular distance from the origin, okay? So for example then, what I'm going to get here is 2, because this mass here is 2, times by the perpendicular distance then from the origin, which in this case here is 2. So we get 2 times by 2 here, like so. This is a summation here, right? So we now add the next product together. So for the next product here, we get 4 times by 5 here, because our perpendicular distance is 5 and our mass here is 4. So we get 4 times by 5, like so. And then finally here, we've got one more particle to deal with. So the mass here is 6, and we times that by the perpendicular distance of 3. Perfect. So this here gives us our numerator. We'll simplify that in just a moment. What about the denominator here? So the denominator, nice and straightforward then, it's just simply the sum of the individual masses here. So 2 plus 4 plus 6. Like so. So let's just simplify here then and see what we get. So 2 times 2 is 4, 4 times 5 is 20, 6 times 3 is 18. Add those together. What we get here then for the numerator is 42. And this is all over then. 2 plus 4 plus 6, that gives us 12. So we get 42 over 12. And if we evaluate this here then, what we get is 3.5. Okay. And don't forget then, this 3.5 here is x bar. Okay. So what that tells us then, so therefore, the center of mass is, so given this here then as coordinates, what we get here then is 3.5 and 0. So don't forget then, the y coordinate here will be 0 if the particles lie along the x-axis. And if it was the other way around, so if the particles lied along, or if the particles lay along the y-axis here, English is difficult. So if they lay along the y-axis here, then in that case, my x-coordinate would be 0. Okay. But there we have it then. So that gives us the solution here to the one practice question for this video. And that brings us to the end then of this video here on the center of mass of a set of particles on a straight line.